In this section, we're going to talk about energy considerations and system operation optimization. Indoor pools have a big energy footprint. There's no way around that. However, there are some things that we can do from operating standpoint to try and minimize that energy footprint. If you've gone through some pool evaporation rate calculations, you'll notice that as you change the air temperature and the water temperature, you can significantly impact the evaporation rate of the pool. The reason we mention this is there are some conditions that we can operate at that sort of optimize, and optimize meaning minimize, the dehumidification load and the energy footprint of the facility. In general, what you're trying to do, and this is kind of an industry rule of thumb, is you want to keep the air temperature 1 or 2 degrees above the pool water temperature. That minimizes your evaporation rate. That's definitely good advice. The only thing is where that starts to fall apart a little bit is when you get into some warmer water temperatures, and the chances of you designing a pool with warmer water is actually pretty high. Elderly swimmers, physical therapy, you're going to see water temperatures at 90, 92 degrees. Clearly, people aren't going to be comfortable in room air that's 94 degrees. So it's important for us to understand we want to keep the air temperature as high as possible while still keeping the patrons comfortable. That's vital. We've got to make sure that our patrons are comfortable. So from an energy standpoint, there are 3 things that we want to consider. Number 1, as we increase the water temperature, we're increasing the evaporation rate. As we decrease the air temperature, we're increasing the evaporation rate. And normally we don't fluctuate too much outside of the 50 to 60% relative humidity range, but if you were to, as you lower the relative humidity, you're increasing the evaporation rate too. So we can use all of these pieces of the puzzle to calculate a load and sort of give an optimum operating condition with the lowest energy consumption, energy footprint possible. We need to introduce outside air into our facility for good air quality and also to meet the local codes. Additionally, we need to exhaust air from the room. We do want to keep it slightly negative pressure. So we have an air turnover that we need to consider. If we're exhausting air that's at 82 degrees, 50%, that's very high energy, high enthalpy air. It's a perfect opportunity to tap into that for some energy recovery. Also, we can pre-treat that outside air coming into the room, and we've got our cycle for energy recovery. A really clever way to tap into these 2 air streams is with a glycol runaround loop. We can size the coils exactly for the CFM of each air requirement, and because it's a very compact coil set that's already been dipped, so it's pre-coated for the corrosion concerns of a pool, fits very nicely into your air handler with a very compact footprint. So from an energy recovery standpoint, a glycol runaround loop is a very nice way to minimize your energy footprint in your facility. If you're designing to meet ASHRAE standard 90.1, you need to either cover the pool with a blanket when not in use, or have some site recovered energy to conform to this energy standard. One of the great ways to do some site recovered energy, if you're using a compressorized system for humidity control, is the pool water heating option. As a byproduct of running the compressors to dehumidify the space, you've got a lot of energy available that you can redirect back into the pool and maintain your pool water temperature. Depending on where you live geographically, this option might even represent 100% of your year's pool water heating requirement. One of the things an owner can do to make sure that their system's energy footprint long-term is as small as possible is to make sure that everything is adjusted and dialed in to peak performance. A way to do that is to embrace some of the technology out there and allow a factory-trained technician, or better yet, the factory, to look in on the machine and make sure everything is adjusted and running at peak possible conditions. All too often these units are installed and forgotten about, and they kind of limp along there and they're using energy unnecessarily. When you've got a system that's adjusted properly, not only do you use less energy, but you also have less maintenance concerns, and you've got a system that in the end delivers exactly what you want: comfortable conditions and good air quality. The days of refrigerants costing $1 or $2 a pound are long gone. Today's refrigerants can cost as much as $20 a pound. So we're looking at some serious dollars here when you've got a system with very large refrigerant charge. Anything you can do to minimize that refrigerant charge has a number of benefits. Number one, for the owner long term, it reduces their liability and potential costs and maintenance down the road if they ever have any leaks. Also happens to be environmentally friendly. It's a much greener system if you've got much less refrigerant, and it's also worth some LEEDS points. So these are all things that really should be driving the design to minimize the refrigerant charge as much as possible. The amount of condensate that the drain pan collects on a dehumidifier is substantial. Over the course of a year, it typically represents one pool fill. So it's a lot of water. Depending on your local codes and what your LEEDS design requirements are, at a minimum, this could be used as gray water. However, a lot of codes allow you to introduce the condensate from a pool dehumidifier upstream of the filter. So this will help you minimize the amount of makeup water you need on your pool. So it's really a good thing to do, to tap into the condensate off of one of these systems. Well, that about wraps it up. Hopefully we've been able to highlight some of the key design criteria for a good indoor pool environment. If you're working on a design or you have any questions, call us anytime. We're standing by ready to help. Thanks so much for tuning in.